here we go. We're off. Let's do it. We've got, who's missing today? Cody's on his way in, right? Julia, we miss you. Casey, we're so sad. We hope that you love Arizona. All right. Isaac. Isaac ain't gonna watch a video, guys. I mean, Casey and Julia, but Isaac ain't gonna watch a video. All right, I'm kidding. Isaac will watch a video because he wants to hear the shout out from Megan.
Feel better.
Feel better. He's not sick. He's skipping. All right. Okay. All right, here we go. It starts right away. Your brain's gonna lock up. It's just gonna totally lock up on you, and who knows what will happen at this point. What do you think U is equal to? So what's du? Oh boy. Really good idea to cube both sides. You can't cube dx. Because we do not have operations of derivatives that involve powers. And so we can add, we can separate through addition, but we can multiply by constant, that's it. Let me try this. So we've got that x, right? We've got the x squared plus 2, which is u, right? We've got the dx. What's the only piece we're missing? How can I get the x squared? Yeah! Squirrel! Woo! She got it! Look! U minus 2 equals x squared, right? Oh, so now, boom! She's got it! We've got it! Now we're golden! Look at that! I was able to see I could rewrite it so I could grab that x squared from another u. So, well, you just substitute. Let's do it. So I'm going to look at this one up here. I'm not going to look at this one. This one does me no good anymore. What do I put in for the x squared? U minus 2. What do I put in for x squared plus 2 to the 5th? U to the 5th. What do I put in for x dx? 1/2 du. Megan, you gave it the look like you would give, like if somebody served you dinner and you didn't like it. That's the look you just gave it. All right. What do you think? Do you see where it all came from? We saw that there was a problem because when we did the derivative, we got 1/2 du is equal to x dx. When we looked at it, we didn't have an x. We had an x to the 3rd. So I created an x. I found I had an x squared. I used the x squared to find the u. Cool. Now we can do it. How do I do this? Multiply through. U to the 6th minus 2u to the 5th du. What's the antiderivative of u to the 6th? Multiplied by 1/2 would be u to the 7th over 14. Okay, I'll write it all up. 1/2 times u to the 7th over 7 minus 2u to the 6th over 6 So this will be u to the 7th over 14 now, right? And u is x squared plus 2. So x squared plus 2 to the 7th over 14 minus, let's see, the 1/2 and the 2 will cancel, won't they? So we got x squared plus 7, or x squared plus 2 to the 6th over 6 plus some constant. What? The 1/2 cancels out with the 2 there. What do you think? Kind of tricky, huh? Oh, goodness gracious. All right, so look at this. What that means is if you took the derivative of this guy right here, what would you come up with? Come up with that. Would you ever guess that? Pretty hard to just see, isn't it? I mean, like, you can look at, the integral of sine. You can say, oh, yeah, well, that's going to be negative cosine. You can kind of think it through. Can't really think that through, can you? But think about multiplying that out 5 times, distributing the x to the 3rd, and then trying to factor it back into that form. Well, that'd just be absurd. All right, let's do another one. U equals x to the 3rd minus 4 du is 3x squared dx. I don't have a 3, I have a 4, so let's divide by 3 and multiply by 4. I get 4/3 du is equal to 4x squared dx. Well, it's a piece of cake. It's from the movie. Let's see. This is, yeah, we'll watch the movie. Trust me. Oh! All right. Everybody okay with that? I rewrote it. So, I rewrote it in terms of x so that I could see the parts that will be substituted for. So now let's write the integral instead of x. Let's write it as u. We distribute. I'm sorry, we now substitute for u. So instead of x to the 3rd minus 4, I've got u to the 3rd. What do I do about this x to the 3rd right there? U plus 4 is equal to x to the 3rd. So I've got so I solve for the x to the 3rd. It's u plus 4 from this. So I multiply by u plus 4. So I took care of that. I took care of that. What do I replace 4x squared dx with? 4/3 du. Yeah. Let's do it. 4/3 times the integral of u to the 4th plus 4u to the 3rd du. 4/3 times, what's the antiderivative of u to the 4th? U to the 5th over 5. We say that like it's nothing. Took a lot of work to get there. Plus, antiderivative u to the fourth, 4 u to the third. U to the fourth, very good. Plus some constant. And now I multiply back through. I've got 4 times u, which is x to the third minus 4 to the 5th power, over 15. It's my broad shoulders. Plus 4, and I got x to the third minus 4 to the 4th over 3 plus some constant. What you think about that? Ooh. Wait till it's not doing trig ones. Oh my goodness. All right, just because you said that, I'm now going to show you what we did in class today. How's that? You're over this. A day full of this stuff. How's that? Does it remember that? Oh, but that was... Oh. All right, say that again.
That was fun.
Larissa Hacker thinks graphing secant, cosecant is fun. You are officially a math nerd. Very good. All right, thank you. All right, I'm with you. I think it's fun too. And next year you'll look back at your math and be like, I remember doing U substitution. That was fun. All right. We tried trig. What? Okay. Good idea. Yep. No, you're right. No. You're 100% correct. So du is? What's the derivative cosecant? Yes. Because it's taken to the 4th power. So if you're going to take the derivative, you would use the chain rule with that part right there. And whatever you would use the chain rule with the derivative is, generally speaking, going to be your substitution. Yes, 5. It's like I've got, I just suppress anger from that time in my life. My God, I've been seeking counseling because of you. All right. Oh, Mike was a great professor. He didn't want us to call him Professor or Dr. Mike. He said, call me Mike. I said, okay, Professor Kahn. He's like, no, call me Mike. Yes, Professor Kahn. All right, negative du is equal to cosecant of x, cotangent of x dx. You do not have a cosecant up there. Or wait a minute. We do. Oh, watch this. Do you see what I did? Yeah. So instead of having a u to the 4th, it's going to be u to the 3rd. And I've got my cosecant cotangent sit right there. Plug it in. So instead of cosecant, I write u to the 3rd. Cosecant cotangent dx gets replaced with negative du negative u to the 4th over 4 plus c. So negative cosecant to the 4th of x divided by 4. hope you think the next one is difficult. Oh. Okay. I'm going to need to do the next one on a kind of a blank area because it's rather large. So 3x squared over 4 through it. We got that? Yeah, okay. Here we go. You want to move it up to top? I don't like that idea at all. You can, without a doubt. Larry brings up a nice idea. Move this to the top. I don't know what for. I don't really like it. But if you want to, free country, do it. But for the purposes of teaching, I will leave it where it is. I will write u is equal to what? 3 minus x. So du is equal to negative dx, right? Oh boy. Oh boy. Watch this. We're gonna add the x, subtract the u, we get x is equal to 3 minus u. Right? I don't want an x, I want an x squared. So we get x squared is equal to I'm just going to throw the 3 up front. I don't really like it. So, I'm going to move the 3 out front. Integral. Yep, yep. You'll take care of the negative in just a second here. Instead of x squared, I have u squared minus 6u plus 9, right? Because I don't like it. I just want to deal with it at the end. I often will put my constants out in front of the integral sign just because it's neater. I'm a really neat guy. Divided by what? The 4th root of u. So u to the 1/4. Right, like that. And then what do I replace dx with? Yeah, we've got, let's see, negative du is equal to dx. So I replace that dx with a negative du. So negative I'll put out there, like Emma said, and I'll put that du right there. Now you just take the antiderivative. Oh boy. Let's see. So this is u squared over u to the 1/4. So in order to do this, yeah. So this is like u to the 8/4. So we subtract our exponents. We get 7/4. Not yet. We got to first write it as a polynomial. We have no idea how to do that. So let's write it as a polynomial. This is u to the 1 or 4/4. So what's 4/4 minus 1/4? So minus 6u to the 3/4 plus, yeah, or this is like 0/4 for an exponent there. 0/4 minus 1/4 is negative 1/4, right? So I'm going to write it as 9u to the negative 1/4 du. I have to write the du because I haven't taken the antiderivative yet. Sure can. No. All I did here was I rewrote it so I didn't have this thing in the denominator because I don't know how to take the antiderivative of that. I do know how to take the antiderivative of this. So basically, it was this type of problem. X to the third plus 1 over x squared. You don't know how to do that. Remember when we did those problems the other day? We divided, we got x plus x to the negative 2, right? And then we worked. So same type of situation, okay? Oh boy, holy cow. This is going to be a mess. Negative 3 times u to the 7/4. Add 1, you get 11/4. U to the 11/4 divided by 11/4 or multiplied by 4 over 11. Because you divide by 11/4 or multiply by 4 over 11. Okay. Minus 6 u to the 7/4 over 7/4 or multiplied by 4/7. So I got 24 over 7 plus 9 times u to the 3/4 divided by 3/4, which is multiplied by 4/3. So 36 over 3. I don't remember what u was. What it's 3 minus x? Okay, last step. 3 minus x goes into there. So we've got negative 12 times 3 minus x to the 11/4 over 11 plus, it's 24 times 3. 72. 72 times 3 minus x to the 7/4 over 7. Oh, the 3's cancel. Yay. That's 36 times 3 minus x to the 3/4. Constant. Negative 3. Then you would divide it by 3, so they'll cancel. So, but hold on, you gotta stop and smell the roses every once in a while. Remember that if you took the derivative of this, you would get that. Who knew? I mean, I challenge you, go home tonight, take the derivative of this, and see if you can make it look like that. Sure. Sure. If you could write that out, take the derivative, and come up with the original, I'll give you 2% extra credit on your test. 2%. 20%. Okay, I only want to do those 4 right now. That's it for right now. Okay. Hey, boys and girls, we got 2 lessons left before we're ready for another test. That's it. Yep. And they're short lessons. So I think we can do tests next week Friday. Raise your hand if you're here next week Friday. How about this? Raise your hand if you're gone next week Friday. Okay. All right. I'll be thinking about it. There's your assignment.